I'm Chanda Turner. I'm the coordinator of family and community engagement for the district. I wanted to welcome you all here today. Thank you for being here. We're just going to take a few minutes to hear from some of the lovely people who made this happen for you. But I wanted to just kick off by saying thank you and welcome. And if you need to keep getting set up, go ahead and do that. But just a few ears. We're going to start today with our superintendent of schools, Miss Jean Crocker. Jean.
Is that okay? Good morning, everyone. So that was really quiet, and this is a huge gymnasium that USM is sharing with us today. So I'd like us to show a little of excitement and enthusiasm this morning about how great it is to be here to celebrate STEM. So get loud, let's clap, let's scream a little bit. Go! Are we excited? All right. Nice. Woo! Outstanding. I knew I could count on you. So I am here as the official and very authentic and honestly thanking person. So I would like to show appreciation to all of the following and others who will be unnamed because an undertaking like this takes hundreds of people. So here go these thanks. First of all, Jessica Evans of USM, who facilitated our use of this amazing facility, which gives us so much more room than we had last year. Plenty of space for the hundreds and, yes, thousands of people who will be with us here today. In general, I'd like to thank USM's facilities and gym staff for making this setup work so beautifully for us. Our good partners, Envirologics, Kathy Brooks and her entire team, we wouldn't be here and having our second annual STEM Expo without Kathy, her team, and everyone at Envirologics. So thank you folks so very much. Our own Kathy Cole and Tina Mickelson, community coordinators who really run the show on behalf of the Portland Public Schools. They take care of the little tiny details right up to things at the very top. Ladies, absolutely amazing. Well done. Second year in a row. Thank you so much. Now a real general shout out to all of the Portland Public Schools teachers and students who are here today, both attending as well as presenting your amazing work. We are so proud of you. You can't even imagine it. Have fun today and just keep doing things STEM related. I'd also like to thank all of our post-secondary partners who are here today joining. This makes this a wonderful continuum of learning in the STEM field. And certainly all of our business partners who have come together to support this amazing work and the learning of our students. And finally, at the Portland Public Schools end, our folks in transportation who have jumped through every hoop that we could possibly throw at them to bring thousands of students here today. And so at this time, I'd like to turn things over to our partner at Envirologics, Dean Layton, the Senior Vice President of Sales and Marketing. Would you please join me in thanking Envirologics and Dean?
Thank you, Jean. It's really a pleasure to be here. And on behalf of Envirologics and our whole team that's here, and our parent company, Ensign Bickford Industries, we really appreciate the opportunity to come and participate in something like this in the community. We had a really good time last year, and for those of you who are here, it was fun. And for those of us that are normally cooped up in the office, to get out here and interact with the youth and kind of stimulate their minds, and we learn from them too. But I know last year I played the bean game with, I can't tell me, hundreds of kids, and seeing the engagement, seeing the lights go on and seeing them get excited is really fun for us. And when we look around and see all of the different exhibits and what these kids are doing. So being part of science and technology as a company is fun, but to bring it to the community and interact with the youth that are going to be tomorrow's leaders is a special experience. So thanks for allowing us this opportunity. And it's my pleasure to introduce Dr. James Graves, who is the Dean of Science, Technology, and Health here at USM, and we thank them for their hospitality in hosting this event.
Thank you, and good morning, everybody. I am Jay Graves. I'm Dean of the College of Science, Technology, and Health at the University of Southern Maine. And on behalf of the university, welcome on this beautiful autumn day. I understand there will be 2,000 students visiting today, students interested in the STEM fields. I like to tell people there's a major for everybody in the College of Science, Technology, and Health at the University of Southern Maine, and I'm expecting 2,000 new students over the next couple of years. Have a wonderful day. This is an outstanding program. I'll be in and out throughout the day. I've already had a chance to visit some of the exhibits. They're so exciting, and I know the kids are going to have a good time. Have a wonderful day.
Hi, I'm Lauren. I'm in 5th grade from Hall School.
Hi, I'm Remy Joe. I'm in 5th grade from Hall School.
Hi, I'm James Tedder, 5th grade at Hall School.
I'm Ben, and I'm a 5th grader at Hall School.
I'm Jenna Quimby, and I'm a 5th grade teacher at Hall School. This is a project that we worked on last June, and I'll let the kids explain what they're doing.
So today we are building electric cars powered by electric motors.
To start the car, you need to cut a few pieces of wood.
Okay, so you cut the wood, and then you have to glue everything together with the wood glue. And then today we are making a giant one right here, which I can't lift up. Everything just fell off of it. But we are using motors, and then there's this little black piece on it, and a motor holder. Battery packs with, there's going to be batteries in them, and wires.
It got too straight, but so maybe you can put it on that side and shoot towards this way. Yep. It goes to the left, so there we go.
Oh, there goes the city. Here. There we go. It's like a game.
I'm Dylan Crovo.
And I'm Kevin Siegel.
We're from Paths, and we've got some 3D printers.
We currently have 3D printers right now, and me and Dylan both work on them at our manufacturing technology class.
What we're doing with this one, because I think it's the most interesting right now, is we're actually printing some parts for it. So this right here is actually a part that goes on the printer itself. These things are very self-replicating, so that's what we're gonna our plan for the future is to print parts for one, buy the parts we can't print like motors, and make our own. You go.
Yeah, we actually made this one last year, and recently just got this one from that we bought from Lulzbot. And both of these machines are actually open source, so we're able to communicate with them and get the schematics for everything.
Exactly, yeah. And then right over there, if you pan the camera, we've got one print starting right now that we've been having a little trouble getting it going, but it looks like it's gonna work right now. You wanna... Oh, that's all right then. And there's two basically main types of printers. You got delta printers like this one, which use 3 motors in a basically triangle formation to move the print head around. And you've got Cartesians like these two, which basically use either a extruder head on the Y and Z axis and a platform on the X axis, or an extruder head on the Y axis and a platform on the X and Z axis.
Yeah, I think that pretty much says everything we got. Yeah, and all these things here, all of these here were printed on this, except for this, which was printed on here, which we just got. And what we're hoping is that we can start producing the printers and actually
Providing them to classes and
provide them to classes and the rest of the Portland public school system, which would be great actually. So, yeah.
Hi, I'm Johnny Sylvain from King Middle School, Windsor 7, and our expedition was Red Rovers. We were given a challenge by the DEP, the Department of Environmental Protection, to build a ROV, robotic operated vehicle, to identify invasive aquatic plants. So we started off here with research. The DEP came in and gave us this challenge, as well as explaining what we would be doing. After that, Josh Sparks, a invasive animal specialist, came in and showed us a few invasive animals that most of us didn't expect to be invasive, like a goat or pigs. Then finally, for the final part of our research, we went to Kettle Cove to find invasive crabs. Sadly, we did not find any native crabs at all, but we did find many invasives. One of which was pregnant with had eggs. Secondly, then we move on to the build, which was the second major part in our expedition. We started building our ROVs. We did this with the help of 3 construction manuals, which in 3 different units. Where first was the frame assembly, then the thruster assembly, then the control box assembly. All crucial parts in making this. As we went through this process, we did many things like cutting PVC pipes, drilling holes into the PVC pipes, and for the control box, soldering the wires so that the propellers and motors would work. And finally, we come to field work. The field work is when we went into the field to learn, to see if we could actually identify these invasive species. First, we went to the YMCA of Portland, Maine, to see what the ROVs were capable of. We did not have any recording then, but when we went to Sebago Lake and Highland Lake, we attached GoPros to the ROVs and also a live action camera, the AquaVu, to see what was happening underwater. And so we did find invasive species at Sebago Lake of variable leaf milfoil, which is a very invasive species. Overall, we made over 60 ROVs, and here are a few being worked currently. They have a forward and back thruster and a motor to go up and down with a ROV in the front to see what was happening. And the last thing that I'm going to talk about is a claw. I'm going to hand it off to Kieran, who's been working on it.
Thanks, Johnny. So I've been working on an extra of the ROV called the Claw. We had some mishaps with this. We made a prototype out of Lego, and it actually does work. Yes, it's a little bit hard to operate, so we had to get something different. Yeah, see? So instead we bought an Armatron, which is an old Radio Shack toy, and we took it apart. This is the whole layout setup that we've been taking apart. And here's the claw that was supposed to go on here. The claw is actually going to be attached to here, and we're not done with it yet. But what's supposed to happen is this motor right here, it's a really small motor, is supposed to go in here, as I built a chassis here for the motor. And the claw, it's going to be moving the claw, and it's going to be attached to the battery, which is there's a battery over there. It's going to be attached just like these motors. And so, yeah, it's going to be opening and closing the claws. This is to take samples of invasive species, not just videos. And we haven't had a ton of success yet, but right now we are waiting on a certain device to cut a hole in the back of this so we can practically finish the project. So right now we're just in an idle point. We're waiting, and it will hopefully be done pretty soon. And Oscar's been helping me on this. And so we've been spending a week or two on this, and it's been in relation to everything. So hopefully this will be able to operate pretty soon.
So we're generating volts of electricity using wind power. For our expedition that we've been working on, it's like what our energy use is and what energy source will sustainably take us into the future, and how our impacts how our choices and energy use are impacting the environment. And what we're doing is, like I said, we're making testing wind blades for a wind turbine to generate volts of electricity. So wind power is a viable use, a sustainable source for energy once we run out of oil and other energy sources.
I don't know what it is. You can tell.
So what we're using is we are using a meter to see the volts of electricity, and a resistor, which is putting resistance on the blades so it's harder for them to spin. So that's a good way to estimate how they would spin with resistance. And so what Natasha's doing is she's changing the resistance of the blades to see which resistance makes it go faster, which resistance makes it go slower, and that type of stuff.
My name is Sophia O'Lory, and I'm from Lyman Moore Middle School. And for our 8th grade project, we had a design challenge to build and design a model sailboat for a downwind race in a 7-meter tank, or a 21-inch tank. This was our winning boat this year with a time of 10.5 seconds. And the reason it was one of the fastest boats, or the fastest boat, was because it was it had a flat bottom, and that reduced friction, because friction is when two forces are rubbing together, and one is going faster and the other one is slowing it down. So a flat bottom boat has nothing to keep friction, so it kind of just glided over the water. The reason they have a big topsail and this tiny bottom sail was because of 2 reasons. One, for support of the topsail, because that wouldn't be too heavy, and also the wind was more hitting this side. They discovered the wind was hitting more the bottom, so they had this sail to push it faster, and also this one to catch any of the top wind. And over there is my friend Reed. He has a demonstration going of the boats.
We did it. Okay. This is the tank that we're using today. The tank that we used in our actual experiment was a lot bigger, probably about as big as this table, and the fan was a lot bigger too. What would happen was we would set boats about either this size or about this size. Really, people or our sizes like those down there, and we kind of just set them in and watch them go down. See, like this one's doing okay. It's taking on a bit of water. So, would anyone like to try doing it themselves? Sure. Just be careful. It's a bit crumbling. It's okay though. It's fine. And just let it go. Yeah, like that. Very good. Anyone? Yeah. Everyone can try who wants to try. Nice. Went straight down. Good job. Yeah. Let's take it out. Yeah. No. And. See, this one, but sometimes they get stuck like that, you see. There's also some other boats. Sometimes they were designed like this. This one would go down, and yeah, want guys let it go? Yeah. But sometimes you see towards the end there, it's taking on a kind of bit of water. It starts dipping in because it just isn't that well supported.
My name's Sadie. I'm from Deering High School. Right here we have a couple of video games that kids can play. They're games that were programmed by Deering students in class in our computer programming class. And then over here we have little things called Little Bits. They're like circuits. You can have them flash or change the dimmers on them. They're a lot of fun to play with. Alright, so this game here, it's called Physics Simulator. If you click something, you're able to spread it all around. So this is something called powder. It's like dirt. And then this is Red Wop. It goes up. Here, I can make this bigger. Goes up instead of down. And then we've got Fire, which lights things on fire. This was programmed a couple years ago by a couple of students at Deering. We also have a lot of other games, like those kids over there are playing a Tron game. You can do 2 to 4 players, and it's basically just like the Disc Wars the Cycle Wars in Tron, where you have to try and cut off the other players, and whoever's left standing at the end wins. There are also lots of other games that we don't have up right now, like Bubble Trouble and...
Wait, are we on TV?
This one's a fun one. If I can get this to open. Okay. Or not. Alright, so it doesn't seem to want to open right now, but Deering programs lots of things like this. Over the past couple of years, there have been tons of games. I've programmed some games, including an I Spy game. Anna, she's going into computer science and started out at Deering. She's currently working on a project in Unity, and while it isn't exactly with Deering, she started out programming at Deering, and she's learned a lot from here. And all of us here are on the robotics team, so we don't have a robot with us right now because we're working on it back at our school, but we're planning on competing in the VEX robotics competition in a couple of weeks, so we're hoping to be able to make it to States again this year like we did last year.